A bubble sort. Um, I, Before I even do any coding with sorting, let's just talk about the concepts and what all of this actually means. So I have numbers, just think of them, I'm using cards, but think of these as an array of just integers, so 5, 2, 6, 4, 7, 3. And a bubble sort goes like this. Okay, it checks the first two elements in the array, if you will, and it asks, do they need to be swapped? We're trying to organize these into smallest to largest. We're trying to sort the data. And so we look at the first two and we ask, do they need to be swapped? And the answer is yes, the 2 needs to be moved to the front. So these two elements get swapped. We swap the elements. Okay, now once that's done, that's we swap the elements, then we move on to the next two. So this item has already been kind of checked, and now I move on to the next two items, the 5 and the 6, and I ask, do they need to be swapped? The answer is no. This then is the smaller of the two, and I slide it over. Then I move on to the next two, and I ask, do they need to be swapped? The answer is yes. So I make a swap, and what I do next is, since the smaller of the two is on the left, I slide it over, and I move on to the next two. Now, if you notice, take a look at the number I'm dealing with here is the 6. And what happens is I'm comparing two numbers, and the larger one moves on. And I compare two numbers, and the larger one moves on. And I just compared the 4 and the 6, and the 6 moves on. So the largest number moves on. That's kind of a big pattern here with bubble sort. So we compare the next two, and we ask, do they need to be swapped? No. The larger number moves on. Okay, and we slide the 6 over into its slot. We compare the next two, and we ask, do they need to be swapped? The answer is yes. We swap, and the larger number moves on. In a bubble sort, actually, coincidentally, the largest number is bubbled, or rises to the top, or the largest number ends up over here on the end, which is great. I've finished my first pass, and in this bubble sort, we're kind of sorting it in reverse order. We're ending up with the largest number on the end, and we'll go and we'll do the next pass. And we'll do the same thing that we had just done. We'll go in groups of 2. And so I'll go groups of 2. I'll ask the 2 and the 5, do they need to be swapped? The answer is no. So the left one moves, the larger one moves on. We compare the next two, the 5 and the 4. Do they need to be swapped? The answer is yes. We make the swap, and the larger number moves on. Okay? And we make the next comparison, the 5 and the 6. Do we need to make a swap? The answer is no. The smaller one slides over, and the larger one moves on. Do we need to make a swap? The answer is yes. So we would make an array element swap, and the smaller number would stay, and the larger number moves on. Now we already know that we have the largest one on the end, that's 7 over there, so we don't need to check that. We just finish like this. And now 2 passes, we have 2 items that are in the correct place, 2 elements in the correct position, and those 2 elements happen to be the larger 2, the largest 2 elements. And so that's basically what happens on the bubble sort. So my third pass, again, I'll just compare a set of 2. 2 and the 4, they do not need a swap. The smaller stays in its position, the larger moves on to be tested. 4 and the 5 do not need to be swapped. The smaller stays in its position, the larger moves on to be tested. Compare the two numbers. Yes, we need to swap these two elements, so we swap the two elements, and now we know that the 5 will be in the right place because the rest of these numbers on the right side are already in order, and the 5 moves on. We have 3 elements left. On my next pass, notice with every pass I end up with 1 number more in the correct order working backwards. So now when I look at these 3 cards that are remaining, again, with my 4th pass I'll have a 4th item in order. I compare these two. Does not need to be swapped. The 2 will stay, the 4 moves on. We need a swap. We swap the 2 cards. The smaller number stays in that position, and the larger one goes to be compared, but there's nothing to compare because we have our nice list over here. We compare the next 2, and they do not need to be swapped, and the second we realize that we do not need to make a swap anymore anywhere in our list, the bubble sort is complete.